Hi everyone. I continue on the lesson topic 4 and this is video number 4. So we have this uh, example here. So the following table shows the conductivity of acetic acid at 25 Celsius for different concentration, and we want to graph it. Okay, so the first thing I have to mention here is what is independent variable and what is dependent one. See, it says we are showing conductivity for different concentration, means the different concentration is something that we have and we are finding, or maybe you a student, you are finding something, you are finding conductivity, you are measuring it. Okay, so this is what you find. The thing that you find is on y-axis, and the thing that exists, so it's just on x-axis. Okay, so I have concentration on x-axis and conductivity on y-axis. The first step is the title. The title shouldn't be concentration versus conductivity, or conductivity versus concentration. No, the title must be informative enough and shows me good information. See, this is the title. So this is my first step. Okay, the second step is you look at the data and see, okay, I have positive values, yes, of course, so I don't need to show 4 parts, I don't need to show all the quadrant. Okay, so I don't need, I just can see just the first quadrant because both of them are positive. Then I need to write both of them for just beside the axis. So I don't write x, I don't write y, I write the thing that I have. So concentration for x-axis for independent one, and conductivity for dependent one on or y-axis. Okay. The next step is just the challenging part, but if you learn what to do, it's very easy and it's very interesting and nice when you try it. Okay, so look at here, what is maximum value for x? Okay, maximum value for x is that, and maximum value for y is that. How about minimum value? Okay, the minimum value is not really large number. For example, if I have, y values, okay, I mean conductivity one. If I have, for example, from 200 to 250, then I really don't need to have from 0 to 200 because it's a large number. But here is 15.5, so it doesn't matter, okay? So I go here, 209, okay, that. Okay, so for x-axis, so yes, so I just do that, okay? Yeah. So what is the maximum value? Okay, 0.1. 0.1 is the maximum value. I divide it between 15 parts. Remember, in quiz or test, you have to count how many parts you have on your graphing paper. Here I do have 15, so I divide by 15. When I divide by 15, what do I find? Okay, 0.1 divided by 15. I find 0. Yeah. So I find 0.006 forever. And I told you, when I have 6 forever, when I have 3 forever, I multiply by 3 because it's not really easy that I say the first one is 0.006, the next one is 0.006 multiplied 2, the next one is 0.006 multiplied 3, because it's hard to write all those numbers. It's very time consuming and it's not really exact because I have 6 forever, so it's just repeating. Okay, so it's hard to show it because I have to round for each part. Okay, so what should I do? Okay, so I know when I have 6 repeating, when I have 3 repeating, I can multiply by 3 and I can show 3 by 3. Okay, so now I multiply by 3. When I multiply by that, I do have equal 0.02. Remember, I still have each part equal this value. Still each part is equal this value, but I am not showing it. I am showing 3 by 3 equals 0.02. Okay, so I start from here 0, 0.02, 0.04, 0.06, 0.08, and 0.1. Oh, perfect. I have from minimum, I have to maximum, I have all the points there. If I see one point doesn't have a space, means I made a mistake. Okay? And remember, I still have part number 1, 0.006 forever, part number 2, 0.006 forever multiple 2, and part number 3, 0.006 forever multiple 3, but I don't show it each part, because if I want to show each part, it will be too crowded, too busy, it's very confusing, it's very time consuming, and I don't want that. Okay, so how about the next? How about for y? Okay, so for y, what is maximum value? 209. Okay, so I have 209, I round up to 210 because this is easier for me. Okay, like the previous example that I did 1900. Okay, so 210. 210 divided by 15. Okay, 210 divided by 15 is 14. Okay, now if I want to say each part is 14, then I have to say 14, then I have to say 28, 14 multiple 3, 14 multiple 4. It's very hard to calculate. Not very hard, of course you can calculate, but confusing, time consuming. You have the chance of making mistake and you don't want that. Okay, so you round up to 15. So you round it. Yes, if I do 15 is easier for me because I can say this is 30, this is 60. See, this one is easy. 90, 120, 150, 180, and 210. Oh, perfect. I have everything. Okay, so I included all my points. So remember, you have this number. Remember, you go up to something easier. You divide by 15. You find the answer, which is here. Okay, you find the answer, which is here, and then round up again because 14, 14, 28, 42, it's harder. Okay, so I just go 15 by 15 because it's easier. I can manage. I can say fast, and I want to make my life easier here. Okay, so I would say this part 4, this part 5, and then I have to find all the points there. Okay, so all the points. So the first point is 0.001. So okay, I have the middle of here is 0.01, and then that's almost very close to 0. Okay, and 15.5, so it is almost here. Okay, so the next one is 0.003, which means you go a little bit further, and 30, so it's almost here. Okay, so then you go 0.01, which means in the middle. Look at that, because I have 0.02, so that's in the middle. 0.01, so that's in the middle, and 63, so I do a little bit here. Okay, so the next 0.03, so it's here, yes, and the answer is 114. So I do reach to here, and then I reach to 105 almost. Okay, so that's here maybe. Okay, so okay, I said 105, and then it must be, yes, close to here. Yeah. Okay, so because it's 114, and then I have 0.1 and 0.1, and that's 209, so close to 210, so it's here. Okay. Oops. Right. Okay, so then I connect them. Okay, finding points and connecting them is also 2 steps, so you have 7 steps here to complete. Okay, and see, I am showing everything. I am using the whole paper. I don't have any points just out of my graphing paper. I don't have any point that I say, oh my god, I don't have a space for them, so I don't need to add a little bit, because sometimes I see a student add some lines here. Okay, you don't need. Okay, we don't want that. Okay, so the next example, you have this device which is a spectrophotometer, okay, or whatever it's called. Okay, so you know much more than me in this case. So it measures the, so this measures the intensity of the light before and after, just it goes through a sample. Okay, and then when we just compare what is absorbed, what is transmitted, so we can say what is the concentration of the sample. So we have that. And so I'm not going to talk about how the device is working, how you have to do here. So no, I don't have really knowledge to say, so I don't. Okay, so you read the question. The question is, you have for a sample of cobalt chloride. Okay, so this guy was measured. Okay, so this guy was measured for just different wavelengths. Okay, so remember, different wavelengths is something that we have. Okay, so that's on x-axis. Okay, so these are on x-axis. Okay, so we measure them, and then we substitute those values here, and we measure a for each one. Okay, how? Oh, it's like y equal x minus 1. So you substitute x and you find y. Okay, perfect. So I have this on y-axis, I have this on y-axis. Oh, I have two. Doesn't matter, I can show, I can manage. Okay, so all the information is here. So this is your independent, and this is two dependent one, which goes on y-axis. And oh my god, I have to show both. Doesn't matter, I do it. Okay, so here I need to, okay, just 1 second. Yeah, so I need to yes, I need to add the title. Okay, so what should be the title here? What should be the title? So tell me about the title. Okay, so maybe we can use the same title that we have here. So absorption, so absorption spectrum for this stock solution of this is between this and this. So maybe I can use this as the title. Yeah. Okay, so I need the title. Okay, so that can be the title. Again, the title cannot be something versus something else. No. Okay, so what should I do here? Okay, I have lambda, which is the wave, I think the wave, am I right? The wavelength. Okay, yes. So I have them on x-axis. Okay, so I can write wavelength, okay, which is nanometer, I think. Yes, nanometer. Okay, so it's here. Okay, so I can make this, and they are all positive. Yes, I do that, and I do this, and I also do this. Why? Because I have two y value. Okay, nice. So this one is this one. How about that? Okay, so this one is transmittance. Yeah, and this one is absorbance. Okay, so that's I don't want to just misspell anything. Okay, so let me see. Yeah. Okay. Right. Okay. This guy doesn't have any unit. Okay, so no unit, because when we calculate we use the log, and logarithm doesn't have any unit. Okay. Logarithm is what Let me think. Logarithm, yes, it's what you you learn in Math 273. But here you just have to use your calculator for log. Okay, so that's a function. So you will see more with more details. Okay, so you have it this one here. Okay, so perfect. So I have the title, I have x-axis, I have y-axis, I have all the units, so everything I need. Okay, so again, the challenging part is the division, and unfortunately here I don't have a space. Okay, so let me see, maybe I can include here. Okay, so I can make it smaller and just include here. Okay, so look at the first one, the first row. The first row goes to 640, yes, but it starts from 400. So I don't consider just for 640, because 640 I know it's maximum, but I don't really want to show from 0 to 400, because I don't have any value for less than 400. So what's the reason I have to include them? And I have to just make my graph very very small for one part, and for a big part I don't use any data because I don't have. Okay, so when I have maximum value, also I have minimum value, but they are both somehow uh, too large number. Okay, so I really don't need to consider before that. Okay, the reason here I didn't do this for previous examples, it was for y values. Look at that, I have 15, and 15 is not really big deal. Okay, so it's a small. So here I have 100, and the other one is almost 2000, so it's not really big deal. So just the big difference. But here I have too large number. Okay, so I really don't need to consider to 400. Okay, so I say, do I have a space? Maybe, let me see, I yeah, so I write it here. Yeah, so I do here. Okay, so for this guy, okay, for this one, I do maximum minus minimum divided by 15. Why? Because I have 15 parts. In quiz and test, you have to count them. Okay, what is maximum? 640 minus 400 divided by 15, which is 240. Yeah. Okay, so it is 240 divided by 15, which is 60. Okay, 60. So I round up and I do it to 20. That's easier for me. Again, if I want to say the first one 16, the second one 32, which is 16 multiple 2, then 16 multiple 3, then it's very confusing. I don't want that. I want to make my life easier. So I round up to 20. Okay, so I do that, and then what do I do here? So I start from 400. So I do 400. Then here is 440. Why? Because I do 20, 20 for 2. So this is 480. This is 520. That's 560. That's 600. And that's 640. Okay? It's okay. So I have two squares just left. That's fine. I did my best. Okay. So the next, for percent, so for percent t. Okay, for percent t, what is maximum value? Maximum value is 98, right? Maximum value is 98. Okay, so minimum value, it starts from what? It starts from 40, but it doesn't matter. It's not again a large number. Okay, it's okay. Okay, so it's not like 400. Okay, so I do, okay, so the maximum value is 98. I round up 200, and then I divide by 15, and the answer is 6.6 forever. Okay, this part is important. Again, I have 6.6 forever. Again, if I want to say the first one is 6.6, the second one is 6.6 multiple 2, the third one is 6.6 multiple 3, it's hard. It's confusing. It's too crowded, and I don't want that. Okay, so I multiply by 3. Okay, if I multiply by 3, it will be 20. So I can say 3 by 3, I go equal 20. Okay, so perfect. So now I start from here, and I say 3 by 3, 20. Okay, perfect. So this is 0, that's 20, that's 40, that's 60, that's 80, and that's 100. Oh, perfect. Okay, so how about the next one? The next one is A, absorbance. Okay, so I do for A, I do here. Yeah. Okay, so what do I have for A as maximum? Okay, for A as maximum is, I think, 0.41. Am I right? Yeah. Okay, so it is 0.41 divided by 15. What is the answer? Okay, it is 0.0273 forever. Okay, how about if I round it to 0.03 forever, for example? Why? Because when I multiply by 3, it's easier for me. 3 forever, 6 forever, I can multiply by 3 and it's easy for me. Okay, can I round that to here? Yes, I can. Look at this. See, I underline that, I check that, and yes, I can round to 3 for just repeating. Okay, so what happened if I multiply by 3? I multiply by 3 and I see that's 0.1. That's 0.1. Okay, so 3 by 3, I go 0.1. Okay, so this is 0.1. This is 0.2, 0.3, 0.4, 0.5. Oh, perfect. I included everything. Okay, so good. Now I can do this, right? Okay, so now I can find all my points here. So I do one graph for these two, and I do one graph for these two. Okay, so 498. Okay, so 400, and so it's 80, so it's 95 here, so it's almost here. Okay, 420, which is here, just here, and 85, so it's, let me see here, this one is 90, and that's almost here. Okay, oops. The next one, 440 and 71. 440, and so 440, that's 60, and that's 70 in just here, almost. Okay, 460 and 54. So 460 and 54. So I have 50, so that's 440, and that's 50 here. So that's 50, and it's almost here. and remember it's almost. Okay, so 48 and sorry, 480 and 47, 480 and 47. So let me see, this is 480, so I made a mistake here, so this must be 460, which is here. Yeah, so that's that, and then 480 and almost here. Okay, so the next one, 540. Okay, 540 is here, right? 520 and 39, so it's a little bit just lower than that. Okay, just very small difference. Okay, 540 and 52. Okay, so now I start to go up. 540 and 52. I know I'm taking time, but I'm doing this intentionally because someone told me I have to slow down. Okay, so 540 and then I find 52, so that's 540 here, and then I do, so 52 is here, just a little bit, right? Yeah. Okay, so the next one is 540. Yes, 560 and 84. So 560 is here and 84 here, maybe. That's just a little bit. Yes. And then just so uh okay, I missed 70, so it must be okay, so 70 is in the middle, so here, and 560, so 560 and 70 is just between them, so it's here, and then 580 and 84, so 580 is this one and 84 is there, and then 688, so it's 688, so that's here. Yes, and 620 and 90. So that's almost, that's, so let me see, it's almost in the middle. So this must be, so in the middle is 90. So that's 620 for 90 here. Just that's in the middle. And then I do this one. Yes. So, and this one 640 and almost that. Okay. Good. So now I can connect them. I can do this. Oops. The problem is when I am just erasing, it erases everything. So yeah, something like that. And it's very hard to it's very hard to do it when I am just sitting on the sofa. Okay, so maybe I do it one more time. So this is here. Oops. And I know it's just almost, so okay. So the next one is going to be green. Okay, so I have where is it? So I have 400 and 0.01, so that's a very low one here, because I have very close to, yes, down, and then 0.07, 0.07 is very close to 0.1. Okay, so 420, and so it's almost here, and then I have 440 and 0. So 440 and exactly in the middle, so 440 and exactly in the middle here, because it's just must be in the middle because it is 0.015. Okay, so and then 460 and then 0.26, so 460, 0.26, so that's that. And let me see, uh yes, so far so good. So the next one is for, okay, so must be close to, okay, so 460 and close to that, so 460 and almost here, okay, and then that's 460. Yes, then I do 480 and more than this. Yes, almost here because it's that. Yes, because it goes 3 by 3, so it's almost that. And so just 0.33 means exactly almost 1/3. Okay, so and then you do 500. You do 500, so 0.4 means this, and then 520, 0.41, 520, 0.41, so a little bit up. Okay, so how about next? So then I do 540 again, so 540, yes, I come down 540, 0.28, so I come to here all of a sudden. Okay, so it's because it's 0.28, then I have 560, 0.16, 560, 0.16, so I come to close to here. Okay, 0.16, yeah, let me see. Yes, it must be 560 and 0 point, okay, so that's maybe 3, and yes, it must be that, so and so it must be here. Okay, and they are all almost. Okay, so the next one, 580 and less than this here, and then 600 and half of that here, and then 620 and this, and 640, and again I come down. Okay, now I can connect them. Okay, so that's here, right? So let me just maybe do it one more time. Okay, so as I said, it's hard to do it on the sofa here. Okay, so then I can do that. Okay, yeah. Okay, so here, right? So these are all approximate. Okay, so but we try our best. We try our best to show everything in just the most accurate way that we can. Okay, so that's just the last step, that I find the points, and maybe you so that's for that question. Now we go to the next question. Maybe for one question you need to calculate on your own. For example, here we have to graph power P and current I with a resistance which is equal to 10,000 ohm, taking a current from 0 to 10 amperes. Okay, so 0 to 10 amperes. See, it's giving you values for x values. Okay, so for independent one, and wants you to find the dependent one. So you have the formula. What is the formula? The formula is 10,000 I squared. Oh, how do I know? I know it from the question. Okay, so what is current? So it's I, and that's ampere, the unit. Power, and that's watts. Okay, yes, it's saying here. Okay, so I can do watts or I can do W, right? Okay, so I have the resistance, that's ohm. Yes, 10,000, I can use it. Okay, so in this case, the data is not ready for you. You have to calculate it. So you have a formula and you want to graph it. So first you substitute the values and you calculate, and then try to do the same thing we did so far. Okay, so if I put 0, what happened? If I put 0, just 0. How about if I do 1? All of a sudden it's 10,000. Okay, if I do 2, so it's 40,000. If I do 3, so it's 90,000, 16,000, 25,000, 36,000. No, it's sorry, it's 25 multiple 10,000. Yes, so it's 250,000. Okay, so 10,000, 40,000, 90,000, 16,000, 250,000. Okay, 360,000. Okay, so because you multiply with 10,000 for all the numbers, so it's 49 multiple. So in order to make it easier, so I do this 49 multiple 10 power 4, and then I do 68 multiple 10 power 4, and then I do 81 multiple 10 power 4, and then I do 10 power 6 because it's 10 squared multiple 10,000. Okay, so I do not need to include 10,000 in my graph because all of them have 10,000. When I see all of them have 10,000, when I see, for example, all of them has, like, for example, divided by 1,000, then I can just forget that part. So I can graph 1, I can graph 4, 9, 16, 25, 36, 49, 68, 81, and 100. But I need to mention, okay, so how do I mention here? Okay, so first of all, I need the title. So the title, power, I have to say, let me see if I can just maybe insert a, I want to be able to type it. Okay, so I can. Yeah. So power produced by current, let me see, what should I, okay, current, maybe through a 10,000, oh, okay, resistor. I think that's informative enough, right? I almost have good information. It's not very long, so, and it says everything about my data. Okay, so that's the first step. Okay, the second, okay, I do this. Okay, so I here, I, which is current, and that's ampere, right? I have that. Okay, so maybe I say current because you would ask, okay, what is I? Okay, so current. The next one is, okay, so here I have to write power. I have to write power, and that's watts. But the most important part is I need to do comma multiple 10 power 4. That's very important. Because it's 10,000, 40,000. All of them have 10 power 4 in it. And I don't really need to include them. It's very confusing again. Okay, when I have just in all of them, I can factor. Okay, but I have to mention in my graph, and then in my graph, I know, oh, okay, whatever value I see, I have to multiply with 10,000. Okay, perfect. So, number 1, number 2, number 3. Number 4 and 5, division. Okay, so what is maximum value? Maximum value here is this and this. Beautiful. Okay, so 10 divided by 15 for I. 10 divided by 15 is 0.6 forever. Oh, perfect. I multiply by 3 and then it's equal to, I don't need to show 1 by 1. I go 2 by 2 equal, so 2 by 2 equal, sorry, 3 by 3 equal 2 units. Okay, perfect. I know here I can do, for example, from 0 to 10. Yes, I know. But then I want to use graphing techniques. I want to show it very beautiful. So I do 0, 2, 4, 6, 8, and 10. This is much better. Okay? So I don't need to just forget 5 parts because I go one by one. Okay, the next one. The maximum for the next one is 100, right? For P. Okay, so for P, 100 divided by 15, the same thing. I have 6.6 forever multiplied by 3, 20. So I do 3 by 3 equal 20. Perfect. Okay, so 20. Now I do 20, 40, 60, 80, and 100. Okay, now I find each point. Okay, so the first one, 0 and 0. The next one, 1 and 1. Okay, so must be 1 and very small here because it's 20. Okay, so almost each one is 6 point something. So I need to be small here. The next one is 2 and 4. Okay, so 2 and 4 here. Yes. The next one is 3 and 9. Okay, so 3 and 9 is almost, let me see, almost in the middle. Okay, so 4 and 16. So 4 and it's almost close to 20. 5 and 25. So it's almost so here. So 20, 30. So it's maybe a little bit here. Yes. 6 and 36. So it's very close to this guy. Okay. So 7 and 49. So 7 and almost in the middle. So here. 8 and 64. So 8 and a little bit here. 9 and 81. So it's here. 10 and 100. Okay. Now I connect them. Right? Very beautiful. Okay. I have the title. I have all axes. I have all the units independent on just x-axis, dependent on y-axis. So I did these divisions. Okay, when I have 6 repeating, when I have 3 repeating, I multiply by 3. Okay, and so I try to multiply by a number. So here is 6 repeating, 3 repeating, so I multiply by 3. Maybe I have to multiply by 4. Maybe I have to multiply by 5. So it depends. Okay, so try to do more example of this type. So empirical and just lab data and these things to make it easier for yourself. And I show my points, and then maybe I do line of best fit. So if I want to do line of best fit is it's much better to do it by Excel. If not, I can just connect them. So it depends what they ask me to do. I really appreciate. Bye.